Thank you, David. Thank you so much for giving me the opportunity to present my paper at the seminar series. And I really appreciate Gary to step in at the last moment to be a discussant for this paper. Today, I'm going to be talking about communication structures in a best shot public good games across three network structures. One of the features, one of the features of strategic interaction on networks is the local nature of information. And one of the implications of that could be that it impedes coordination across different blocks, across different components of the network. So, which has been widely observed in the experimental literature, that there is very low levels of coordination on the Nash equilibrium, and you find you find very good local coordination, but not very good global coordination. Second, individuals might not be fully aware of the full implications of their actions because the information they get is localized. So one stylized facts looking at public good games and networks find that there's an inverse relationship between the number of neighbors you have and your likelihood of investing. And you can think from a social welfare point of view, if people who have more neighbors invest, that would increase social welfare a lot more efficiently. And these kind of actions have long-term consequences. For example, Katz et al. Showed theoretically that if we keep the components of the network separated, you could have persistence of inequalities of people who are in the periphery. And one such example is the caste system in India. And Munshi and Rosenweig in the paper find that people who in villages don't get even access to basic local public goods like sanitation, schooling, or health. And he finds evidence of very good intra-group cooperation. So within the caste, people are very, very well cooperated, but very low inter-group cooperation. So there is not much cooperation between caste members. And the brunt of it is borne by people who are from the lower caste and has subjugated to being on the periphery for centuries. Similarly, Banerjee and Somanathan finds that when social fragmentation increases, we find a lower provision of public goods in India. Even in artifactual field experiments, we find that just knowing that there are people from different social groups could lower cooperation in games. So what I'm interested in this paper is to look at how networks and how network structure and communication interact with each other in influencing the outcomes we are looking at. From the literature, what we know so far is that network structure influences the behavior of individuals in games and strategic substitutes. The Charnas et al. Paper in Econometrica nicely summarizes this. The equilibrium selection is based on groups coordinating on the secure equilibrium, where the maximum number of people are investing in the group, which is at odds with efficiency. So there is this friction between stability and efficiency, which has been noticed. Communication has been effective in coordination games and networks, and there are a slew of papers which show that when you allow people to communicate, they are more likely to coordinate on the Pareto efficient equilibrium. Choi and Lee points out that the structure of communication is really important in determining how the total social surplus in a battle of sexes game is divided between people. So that's one of the ideas which is going in this paper, is looking at different communication structures. And the second, which all these papers which are looking at these coordination games are either complete or symmetric, which is in the case of the Charnas et al. 2019 paper. But very little is known about what's the effect of introducing communication in games of strategic substitutes in networks. Most of our findings are for public good games in complete networks. Second, not much is known about how communication structures would interact with these asymmetries of the network structures. I would like to just go through a quick example of a simple asymmetric network and show that how communication could affect potentially on the equilibriums or on the outcomes groups coordinate on. So imagine there are three neighbors, there are three farmers who share their fields, farmer A, farmer B, and farmer C. They can And a farmer can only observe what the person is doing with whom they're sharing a field. So A and C can only observe what B is doing, whereas B in this case is central in this kind of a network and can observe what both A and C are doing. So in every period, suppose they're playing a repeated game where they decide whether they want to invest in a new technology, learning about a new technology, or simply look at their neighbors and copy from them and not pay this high cost. So one equilibrium would be that B invest and A and C are not investing in this structure. The other equilibrium, which is what Chanas et al. Finds is more likely to be observed, is where people in the periphery, A and C are investing, and B is not investing and free riding of their investment. Here, communication can be very critical. If we allow for all the group members to communicate, and this is a repeated game setting, we could have scenarios where we could have strategies in which people are alternating between these two equilibrium, which is a bit more equitable than just being on this equilibrium where B over a period of time keeps on getting richer, while A and C, who are on the periphery, keeps on footing the bill for B's wealth. The other communication structure we could think about is, which is much more natural for big networks, is only letting the neighbors communicate. So A can communicate with B, but B can communicate with both A and C. In this scenario, you can see that essentially the communication structure is superimposing the structure of externalities on people, on people who are connected in this setting. So this brings to the two research questions which I have. The first is that, can communication countervail the local nature of information? So if we allow people to communicate with each other, does it help with both with local coordination and with coordination on Nash equilibrium profiles? And second is that, does the structure of communication matter? Is it always better that we let everyone communicate, or is it sufficient to just let the neighbors communicate, which might improve local coordination and de facto the coordination on Nash equilibrium profiles? And I do this in across three network structures, and there are two communication structures. The first in which everyone is communicating, and the local is where only neighbors can communicate. And the three networks which I pick up in this is the line, asymmetric, and circle. Some central features of these are there are two people in equilibrium. The efficient equilibrium is the one in which there are two people investing, while in line and asymmetric you have a variation in the number of neighbors they have, and they also share the same secure equilibrium where three individuals are investing. Do you guys have any questions up till this point before I get into the game? Okay. So the game is that agents simultaneously decide whether they want to invest or not invest in a local public good. An agent gets a benefit of B if they invest in the public good or they have access to the public good. So in this example, B and C are investing, so they get they get the benefit of B minus C, and of B from investing from the public good, and they pay the cost of C, while A gets the benefit from B and C gets the benefit from, and D gets the benefit from C. Note that E is not investing and neither is his neighbor investing, so E ends up with 0 in this round, in this example. So consider a Nash equilibrium where B and E are investing. So you can see that with best reply for this kind of a game would be that you invest if nobody else in the neighborhood is investing, and not invest if at least one of your neighbors are investing. So in this case, A has to best respond to both B, but B has to best respond to both A and C. And similarly, C is best responding to B and D. So there are many places where there could be failure of local coordination in such a game. And if you look at Nash equilibrium, you're seeing that essentially unconnected agents have to coordinate their actions, and which is B and E have to invest, and A, C, and D, who are not seeing their decisions of people they're coordinating with have to coordinate this action. And that is where I think communication could be really effective in bridging these kind of strategic uncertainty. So in the global communication, everyone can gain information and verify the information about the choices of all group members. So if A is thinking, did E invest, then he can ask B about it, for example, in the last equilibrium. Similarly, E can verify if B has invested from A and C, because here again, the information each individual has is about their own payoffs and how many people in their neighborhood has invested. So they don't know exactly who has invested. So there is very limited monitoring in this kind of setup, and the global structure kind of gives you the advantage to verify, the opportunity to verify and to exactly know who is investing and not investing in these scenarios. Whereas in the local, it can improve coordination between just neighbors, but it also has this, since all these networks are connected, we could have the scenario that A communicates the action to B, B can pass on the message to C, C can pass on the message to D, and you could have the same full information aggregation going on in such a network. But notice that in this case, C is kind of the bridge between these two sides of the network and could actually play it to its advantage by not investing and only just passing on the information. And that is something we would see on how people coordinate on these equilibrium profiles. So the experiment design, I had 180 subjects participate over 12 sessions. Each session consisted of 3 stages of 10 rounds each. So it was repeated. They were across within the stage. They were assigned a position and a group, and that was held fixed during the stage. Across the sessions, we varied the network. So people who only saw one network structure. So how the experiment was run, people always, the subjects always saw the baseline first, where they knew that investing would give them a benefit of $1 and it costed 75 cents to invest. And they would see either the global communication first, in which they could communicate with all group members before making their decision for 1 minute, or it could be the local, where they could only communicate with their neighbors. So this was kind of implemented. Think of it as like your Twitter wall or as your Facebook feed. People wrote messages on their message board, and people who are connected to them could see these messages within the 60-second time. And similarly, in the communication stage for local, you could only see messages which are sent by people who are your neighbors. So C could only see the message of B and D. Do you guys have any questions so far? Okay. So overall results, what we find is both for line and asymmetric network communication, both the communication structures increase efficiency, which is basically defined by the maximum possible earnings for the group divided and as the denominator, and on the numerator is the actual realized earnings. And we also, what is interesting, we find is in the symmetric network circle, only local communication structure is effective in increasing efficiency. So the 2 questions which I'm interested in is, does this increase in efficiency come from better coordination? Does it kind of countervail the local nature of information? Second, what I'm also interested on, what are the actions which the groups coordinate on based on these two different based on these 2 communication structures. So what I find is that this graph is basically looking at the average amount of best reply, which is to invest if nobody else is investing, and to not invest if at least one of your neighbors is investing for the whole group. So what we find is, as compared to the baseline, in line and asymmetric networks, you see an increase in the rate of best response to their neighbors, which is kind of expected, at least with the local, where you're just communicating with your neighbors. And you see both the communication structure kind of improves this from the baseline. Whereas in the circle, you find that when everyone is talking to each other, it's very hard to coordinate with each other, and you find a lot of coordination failures, and not these differences are not statistically significant. It's only when local communication is allowed, when you can only communicate with your neighbors, you the amount of the fraction of people giving best responses increases. So what kind of does this lead to kind of global coordination on the Nash equilibrium profile? What we find is in the baseline, which is very consistent with the literature, we find only 17.5% of observations are actually consistent with an equilibrium. What is interesting is that when communication is introduced, both line and asymmetric, increases the amount of observations which are consistent with an equilibrium. What is also very interesting is that where B and D investing is not an equilibrium, but we find this consistently groups coordinating on this equilibrium profile. I'll go over it more detailed in the coming slides. And what we observed before, that it's not shocking that for the circle, there is not a huge improvement in the number of in the proportion of observations which are consistent with an equilibrium in the global, because people are not giving best reply to their neighbors. And this rate improves when it is constrained, when communication is constrained to just neighbors. So since this is a repeated game, there are dynamics which can take place. So if groups care about equity, one dynamic which could work is that A, C, and E invest one round and B and D invest. So on average, people are investing half the number of rounds. If groups care about efficiency, one dynamic which could come up is that B and E are investing in one round and A and D are investing in the other round. What we observe is that when it's global communication, when all groups members can communicate, 94% of the observations are consistent with the equilibrium, where A, C, and E are investing and B and D are investing in separate rounds. So groups do care for equity when in these asymmetric networks. What I mentioned before, that in this kind of a local setup, C is kind of the bridge in the information network. So you find when you have local communication, when you're only letting neighbors communicate, there is the number of observations which are consistent with equity only falls. So it's about only two groups are consistently alternate between equilibria which promote equity. More groups are alternating with the equilibriums in which it is promoting efficiency, and one of the reasons is that C is kind of central in this information network which they are exploiting. For the asymmetric network, what I find is that theoretically alternating between the three pure strategy Nash equilibrium is the one which promotes equity. But what is observed is A, C, and E invest in one round, and B and D are investing in the other round. And this is, and for efficiency again, B and E invest in one round, A and D are investing. So what we observe is 25% of decisions are considering with this behavioral equilibrium. Half of the groups are alternate between A, C, and E investing and B and D. So note that they have never experienced the line network to have this equilibrium. So they came up on their own through the chat to consistently alternate between these two strategies. And in the global, we find again that only two groups basically alternate between the two efficient profiles. But once we have local, we find this behavioral equilibrium extremely sensitive to the communication structure, and individuals, there are only one group which consistently alternate between these, and groups kind of value the overall efficiency. So like looking at people which means that people who have more neighbors are now investing in these equilibrium. So kind of people are seeing the full implications of their actions could change behavior. While in the circle, has the largest pure strategy Nash equilibrium is really, and everyone has the same incentive to invest or free ride on the investment of other people in the group. So global, as I pointed out, doesn't really improve coordination, or there are no patterns, but with local, there are no consistent patterns across the circle network, apart from one group kind of alternating through all the 5 equilibriums across 10 rounds. But it does lead to better coordination and and as theory would predict, since all of them are efficient, it's hard to predict what would be a consistent pattern. What has been widely observed in the literature is that inverse relationship, which I mentioned initially, where people are not really aware of the full implications of the actions, and we find that there's an inverse relationship between the number of neighbors they have, an individual has, and their likelihood of investing. And what we find is in the line, since people are alternating, these likelihoods are not different, but in the asymmetric network, we actually find in the baseline this negative relationship, but once you allow for communication, this relationship flips. And in fact, compared to people who have one neighbor, people with 3 neighbors are more likely to invest. So concluding, in absence of communication, I find this negative relationship between the number of neighbors and the likelihood of investing, which is very consistent with the literature. And there is no evidence of a repeated gain dynamics. But both communication structures are successful in kind of countervailing this local nature of information, and groups in both line and asymmetric networks kind of gravitates towards actions which promote equity. And the structure of the network is really, of the communication network is really critical, as you've seen that in the line network, individuals in position C kind of exploit their central position and end up not investing and just relaying information. And you can see that in the asymmetric equilibrium, the behavioral equilibrium where A, C, and E investing in one round and B and D investing in the other round is kind of sensitive to the communication structure, which is kind of expected. And in the local communication structure, we find it's only local communication. In the circle structure, we find that only local communication is successful in raising efficiency. Thank you so much. And you can reach me at my email at prithvijitmukherjee@gmail.com.